Welcome to Chill Skills Sporlan Tech Talks. Thank you all for those who have been patiently waiting for us to start, and welcome to those of you who have just joined us. The topic for this episode is supermarket liquid line components, and we're going to discuss solenoid valves. Now, just to remind everybody to be safe and do smart things amid this coronavirus emergency, and I guess this makes things like webinars a really good idea. This is the fifth in a series of presentations that will follow the agenda of the old supermarket seminars. In the past, Sporlan had a team of professionals on a supermarket team that went around the country to facilitate these presentations in person. With this Tech Talk entry, we are bringing the supermarket seminar concept back and hopefully servicing a bigger audience in the process. We do have an upcoming webinar scheduled for April the 16th, if I got the date right. We're going to discuss thermostatic expansion valves and the role they play in amongst liquid line components. Just a few notes and a few instructions for you. If the speaker on your computer doesn't work, you can simply dial in with your phone. There should be a phone number somewhere on the invitation that you originally received for the webinar. And please mute your microphone. I was going to say something smart, like we really don't want to hear anything you have to say, but we've got everybody muted, so we don't get to. As we move along and you have questions, type those questions in the Q&A window. We plan to answer questions live as best we can. If we run out of time to answer any questions during the webinar, we will post answers online. And just so you know, we are recording this webinar and it will appear on Facebook Live and then eventually on our YouTube site so that you can go back and listen to it at your discretion. Hello, I'm Jim Jansen, Senior Application Engineer for the Sporlan application team. That's me on the left. My stunt double and technical backup today, again, is the ever intelligent and ever, how should I say, live wire, Glenn Steinkoenig. Glenn is a product manager in the marketing department, and he also collects a paycheck from Sporlan. Say hi, Glenn.
Hello, everyone.
Now, you know, Glenn, there's always a third person in the room with us. You know, she kind of acts like the producer, the director, tells us what to do, tells us to advance slides, tells us not to advance slides, tells us to talk slower, to talk faster, to not talk at all. But generally, we just don't even pay attention to her. But she's here with us, nonetheless, to keep me from saying something I probably shouldn't. So, hi, Phyllis. If you have any follow-up questions or feedback, you may contact us by email or contact the Sporlan Technical Support Team at svdtechsupport@parker.com, or you can always call area code 636-239-1111. A human will answer the phone and direct your call accordingly. Now, here's a depiction of a multiplex system and the entire vapor compression refrigeration cycle. It shows the heat rejection, heat transfer surfaces, the refrigeration plant in its entirety, including compressors and metering devices and all the other ancillary devices. If someone wanted to learn more about our typical introduction to this, Glenn, where could they go?
Well, you know, we've done previous videos where they could also go to see this and these webinars. They could also go to any of our bulletins. And then, Jim, I know there's one more in there that I'm missing. Surely you can come up with it.
There probably is. But today, we're going to go ahead and talk about solenoid valves in the low side of the system here in the liquid line. Or, excuse me, low side of the system. You let me mess up there, Glenn. That's not the low side of the system.
That's the high side.
That's the high side of the system, the liquid line. Now, for those of you who've been paying attention, we have done some previous seminars on solenoid valves. Our Henry Papa down in Florida, very smart young man that's working for us, has some prior webinars that go into depth on this subject. Right, Glenn? And where could you find those?
Oh, we can find those on our YouTube channel, and I am sure on our Facebook feed.
Perfect. We wanted to give him some credit because he's put a lot of effort into this in the past. Now, what is a solenoid valve? Well, it's an electrically operated device with a primary purpose to control the flow of fluids liquid or vapor in a refrigerant plant, in a refrigeration system. A solenoid valve is operated by opening and closing an orifice or a port in a valve body that permits or prevents flow through the valve. It is controlled by an electrical current running through a solenoid coil. When the coil is energized, a magnetic field is created, causing the plunger in the valve to move in an open or closed position, depending on the design of the solenoid valve. The parts of a basic solenoid valve consist of the valve body. And I tell you what, Glenn, what we could do here is use our laser pointer and point out the body of the solenoid valve here. That's it, isn't it? Isn't this the solenoid valve body right here?
That is it.
Yeah. And the inlet connection, here's the inlet connection, the outlet connection, the solenoid coil, and then the coil windings are in here, which we really don't detail those all that well, but they're back in here. The coil windings and the lead wires in a junction box. Here's a junction box over here. A plunger, that's some of the internal parts, the kickoff spring, a disc, a piston, or a diaphragm, and of course, the valve port down here. Sporlan offers a wide variety of solenoid valve sizes and styles, which may be employed in a refrigeration or air conditioning system to electrically control refrigerant flow. Now, here's a little bit about how they work. The solenoid valve operation is based on the theory of the electromagnet and is electromagnetic. The solenoid valve coil sets up a magnetic field when electrical current is flowing through the coil itself. That makes sense? If a magnetic metal such as iron or steel is introduced into the magnetic field, the pull of the field will raise the metal and center it in the hollow core of the coil. By attaching a stem to the magnetic metal or plunger, and here we've got some depictions of that over here with the field being generated, this principle can be used to open the port of the valve. Here you see that flux density, if you will, of the magnetic field. Right, Glenn?
Correct.
Thanks for pointing at magnetic lines of force created by electrical current passing through these wires. It's like magic. When the electrical circuit to the coil is broken, the magnetic field will collapse and the stem and plunger will either fall by gravity or be pushed down by the kickoff spring, again, depending upon the design of the solenoid valve. Solenoid valves are usually classified according to the stem and plunger action and the design that goes along with that. The two types being direct acting in design or pilot operated in design. With a direct acting solenoid valve, the plunger, and here's the direct acting version over here. In a direct acting solenoid valve, the plunger is pulled directly off the main port in the valve to an open position, and it thus allows flow through the main port to take place. Over here on the right is a pilot operated version. Now, the type of construction of the direct acting valve is typically limited to smaller valves with port sizes of less than, what is that, 1/4 of an inch, Glenn? Does that make sense?
Yes, it does.
Sporlan solenoid valves with this design type are in the category of Sporlan designations with A3, E3, and what's another one?
The W3.
W3. The flow for these types of valves is limited to applications with relatively small requirements, or it's limited to applications with minimal available pressure differential across the valve port. While the direct acting valve can operate at very low pressure differentials, Sporlan does recommend a minimum of a 1 psi pressure drop up to and including the valve's maximum rated pressure differential, regardless of the line pressure. Pressure drop across the valve port in this particular valve is not required to hold it open. Now, in a pilot operated valve, the stem and plunger assembly opens a pilot port. This releases the pressure on top of the disc, piston, or diaphragm, allowing it to move upward, opening the main valve port. And here you can see some of the internal parts that constitute that. Here's a vent hole. Here's the main port. There's a pilot port in here, which isn't depicted real well, but we're going to show that to you in detail in just a moment. And then, of course, this is the so-called normally closed version, and we're going to talk more about that in a very short period of time as well. In fact, we'll talk about normally closed versus normally open in some degree of detail. So here's an animation that will show how this actually works. And as you see, the blue arrow is depicting flow of refrigerant. That pilot port opens, and thus allows the main port to open. And then these small round blue balls are depicting the flow of refrigerant through the valve. Now, when the coil is de-energized, the pilot port closes, the main port closes, and we're done. It's just that simple. Yes, Glenn, you got a comment you wanted to make.
We do have a question. I think that this is a perfect time to hit this discussion. So how does pressure drop come into play on a pilot operated valve? If the valve is slightly oversized, will the valve not open because of pressure drop? And what happens when the valve is undersized? Does it stay open? So I think the answer to that first question, which is if the valve is slightly oversized, it is possible that there will not be enough differential pressure to actually pop that seat open and actually allow the main port to start flowing refrigerant. That is why we have a minimum required pressure drop. Okay.
Yeah, and I think it's fairly low. If I'm not mistaken, it's 1 psi pressure differential at what would occur maybe at the lowest load condition for full operation.
And if the valve were to open, it is most likely that it will also shut, but it could not necessarily shut because you don't necessarily have all the right conditions for that to happen.
I think that's a fair statement. Yes, sir.
So sizing is absolutely critical to the right pressure drop. Is that right, Jim?
Oh gosh, in fact, that's one of the main points that we're going to detail in just a few slides.
Okay.
Absolutely. A good question, by the way.
Yeah.
Now, there's also, I alluded to this earlier, two basic types of valve operation with respect to whether they're going to be normally closed or so-called normally open. And this has to do with the reference point of de-energizing the coil. A so-called normally closed solenoid valve is closed when the coil is de-energized. And the normally open valve is open when the coil is de-energized. Now, probably the vast majority of valves out there, I'm just going to guess, Glenn, are normally closed. Does that make sense?
That does.
Yeah, but we make both. A normally open solenoid valve operates very similarly to the normally closed type. And you're going to encounter these from time to time, and you can visually determine one from the other in our product line based on the way the coil fits around the enclosing tube. On the normally closed version, you see here the fastener that attaches the coil to the whole mechanism, the enclosing tube, if you will, is fairly flush. While on the normally open version, you see that it penetrates it and protrudes beyond the perimeter of the coil. The system pressure is utilized to open and close both of these pilot operated valve designs. And the big difference between the two has to do with normally open construction is simply with the coil de-energized, a spring can be used to push the stem and plunger assembly upward, holding the pilot port open. This allows the disc to rise because the pressure of the difference between the bottom and the top of the disc then allows flow to actually take place. And that's really the big difference between these two. And you typically wouldn't attempt to substitute one for the other.
Correct. It would probably, the system would not work properly.
Simply not going to like that. When the coil is energized on a normally open valve, the stem and plunger assembly is pulled down into the magnetic field. Okay, so here's the solenoid coil, and that magnetic field here would be occurring, and it would pull this assembly down, causing the stem to close the pilot port. The pressure on top of the disc then equalizes with the incoming pressure, and the disc moves down, closing the main port. That valve will remain closed as long as the coil is what? Energized. So to wrap that up, when normally open valves are energized, the stem and the plunger move down, causing the stem to close the pilot port. That's something I've oftentimes had trouble wrapping my mind around. How can when you energize the coil, can the valve be open or closed? Well, it all has to do with how the parts all fit together, and it's really helpful to have this cross section to see that.
Absolutely.
Now, solenoid valves can be installed in any number of locations in a refrigerant system. Now, we were talking primarily about it with respect to the liquid line, but they can also be installed not only in the liquid line, but also in the hot gas or discharge bypass line. They can also be installed in the suction line. Those are also common applications. The model of solenoid valve to use depends on the function, flow capacity, type of operation needed from the valve itself. And always remember, always remember, one of the key points with this whole presentation, solenoid valve should be sized with the proper port size for the valve flow capacity that meets the application requirement. And Glenn, what does that ultimately mean?
It means you should never size your solenoid valve based on the tubing line size. It's all about the port and the flow capacity and getting the proper pressure drop. And Dan, I think that's the reason why on your half-inch liquid line solenoid valves not normally being used on discharge or suction line gas applications.
Oh, that was a question that came in.
That was a question that came in.
Yeah.
And I think what's happening there is you're most likely going to have an incorrectly sized valve, because the valve should be sized based on the capacity and not on the line size.
Right. Now, so what do you use for selection criteria? Well, first off, a pilot operated valve is going to require a minimum of a 1 PSI differential pressure to operate properly at minimum load. And that's an important part that sometimes people overlook. Direct acting, well, you know, the plunger gets pulled directly from the port, so that's less of an issue there. From an application criteria point of view, we need to know the capacity. What's the flow that is needed through the valve? And this used to be something, this next item I'm going to mention, used to be something I took for granted. But in this day and age, with the plethora of refrigerants that are on the market, knowing the
refrigerant
in the system is crucial and can be, in fact, maybe a little difficult to determine in some instances if you're going back to service an older system that might have been retrofitted once, twice, or even more times. Application, is that valve going to be in the liquid line, the suction line, or even the discharge line? Does it need to be normally open or normally closed? We make specialty coils for each instance. There's always been this tendency in the industry to select solenoid valves based on the line size. In other words, if a liquid line solenoid valve is being selected for a system with a 5/8 inch OD liquid line, there's a tendency to just simply install a valve that had 5/8 ODF connections. Did I say that right? ODF, yeah.
Yes, you did.
Yeah. However, due to the pressure drop required for proper operation, as we previously discussed, going down that path is risky and can get you in big trouble. So what's the thing to remember here, Glenn? What is it?
Never select your solenoid valve based on the line size. It's all about system capacity.
Absolutely. Now, here's a reason for that. In addition to the pressure drop thing, the issue that can get you in trouble take this example. Here's an R410A system. It's 15 tons. We have multiple solenoid valves with, as you can see, 5/8 fittings on them, ranging from the E8 to an E19, with capacities at a 3 psi pressure drop that range from 6 tons up to almost 23. Now, it's quite possible that you could go into a supply house and theoretically grab any of these 4, install it, and without realizing that you're going to have some problems potentially. So to avoid difficulty, solenoid valves should take into account the capacity needed, refrigerant in the system, and the pressure drop that's going to be there to make it operate correctly, and not base it on line size. Once you have selected that valve, selected based on the system capacity and refrigerant, then the product literature, if you go that route, may be reviewed to determine which connection options are available for that particular size valve. Here we've got an example of an E14 that shows different fitting combinations, and then depending on the pressure drop in the system, a wider range of capacities. The E14 series is available in the following connection sizes, 5/8 and 7/8. So all the more reason that what, Glenn? We don't size solenoid valves
based on the line size.
Thank you.
It's all about the port size.
Absolutely. Now, an option to consider also with valves in general is the so-called manual lift stem. Many of our larger solenoid valves are available with this optional feature. It's a really handy thing. It allows a service technician to be able to physically open the main port of a normally closed valve without electrical power being applied to the coil, or in the event of a coil burnout, or for any other service reason. A manual lift assembly is designated by the addition of the prefix letter M as in manual at the beginning of the valve designation. Now, the manual lift stem cap, as you see right here, makes the final seal. Oftentimes, I've gone into the back room, mechanical supermarket rooms, and I'll find a row of valves without the cap installed. That's leading you down a path of what, Glenn? That's not a good thing.
Potentially, you have the opportunity for external leakage. And nobody wants to buy gas if they don't have to.
Right. Absolutely. So always apply the cap. And for those instances, and I know there are some owner operators that after commissioning would like to see these removed from the system, we do have a plug that's available that can be installed, and then that removes that feature. And unfortunately, now you don't have that. But we've got an answer for a way to be able to open the valve without that. And that's this solenoid service magnet that we offer. So we have a solenoid service magnet, which is useful and handy accessory to have when servicing solenoid valves. If the valve is not available with a manual lift stem, or if the manual lift stem was removed, you can still open the valve without electrical current being applied to a coil. The magnet can be used to manually open the valve. This is done by first removing the solenoid coil from the enclosing tube of the valve and placing the magnet on the enclosing tube in place of the coil. The valve remains open until the magnet's removed. And that would allow the technician or the person servicing this system to temporarily open a solenoid valve during power failure, or in the event of a coil burnout, or for any other service need. Now, just something to keep in mind, these service magnets are what do I want to say? They are capable of flight. And if your back's turned to them, they tend to simply disappear. And you know what I'm inferring there. They are a hot commodity if left in a control room. So what do? Maybe you buy a few extra ones just to keep them around. Just saying. Now, Once a solenoid valve model has been selected and the desired options are appropriately determined, the proper coil must be selected based on the solenoid valve type and the electrical characteristics required for a particular application. For normally closed type solenoid valves, Sporlan offers the MKC1 and the MKC2 coils. You can refer to the part number of the solenoid valve to determine which coil is needed. Now, one thing that's really handy is we have Bulletin 30-10 and Bulletin 122, which is our parts bulletin, both of which are available online at www.sporlan.com. You can review them, download them, and they're really expensive, right, Glenn?
Terribly expensive, Jim.
Yeah, what's the price?
$0.
Yeah, they're free. Good resource for those of you in case you didn't already know about it. The number after the connection style letter signifies which type of coil to use for the particular valve. In the previous example, the solenoid valve, say at ME6, had a 1 after the connection style size of, in the letter S. Therefore, it requires an MKC type 1 coil. That fits an ME6 type solenoid valve. For normally open type solenoid valves, a letter O is present at the beginning of the valve in coil part number. Normally open valves require either the OMKC1 or OMKC2 coils. Again, the number after the letter S designates which coil to use. So if the valve was an OE14S250, the coil needed would be what, Glenn?
An OMKC2.
Perfect. That's almost straightforward enough for me to keep it straight. Because of the physical characteristics of design, rapid cycle valves also require this normally open style series coil, even though they are normally closed valves. And that's because of the way we need for the internal parts to mate up with the field that's created by the coil itself when it's energized.
Mm-hmm.
Solenoid coils for Sporlan valves are available with various voltage options for AC or DC applications. Now, we've got a fair number of them listed here. The most commonly used are AC coils rated for 24 volt, 50-60 cycle, 120 volt, 50-60 cycle, and then the 208, 240 volt, 50-60 cycle versions. Solenoid coils with a conduit boss rather than a junction box are available to satisfy the NEMA 4 rain tight requirements and have an ingress protection rating of IP55. Glenn, it looks like you've got another question here. Am I correct there? Do you have a question?
We do have a question.
Is it something we can answer?
I believe it is something we can answer.
Okay, go for it.
So the question is, can you use a service magnet during a vacuum? The answer is yes. Now, there's a second part of that question that I have to admit I'm not 100% clear on.
Well, we'll make something up.
Will that open the main port, Jim? And so the right answer would be, I think on a direct acting valve,
there'd be no question.
Absolutely. On the other one,
well, the intention is that it opens the metal parts inside the enclosing tube would be affected by the operation of that, and so it would ultimately open the entire valve. Or it's sort of like what's the use?
Right.
Here we got a little troubleshooting menu for solenoid valves. So let's say the valve will not close. Well, what are some potential causes for that? A valve will not close.
Yep. Too little pressure drop is typically a lot of what we see. Of course, the other two can also happen. We do occasionally have debris in our systems. That's where a good catch-all would come into play and protect your solenoid valves.
Absolutely.
But occasionally, due to voltage spikes or whatever might be happening in the electrical system, or other things that could come across or damage the coil, you could have a coil failure.
Now, let's say the valve won't open. What's the potential causes there?
Well, it's typically an electrical issue.
Okay.
So either the coil failed or you have some wiring issues.
Okay.
If your wiring is like my wiring that I do, you might want to go back and double check it twice.
Oh, okay. Gosh. All right. We need to keep that in mind. And we're doing good here. So we're moving on to rebuilding solenoid valves. And for any of our internal support staff that would want to know, I'm on slide 23 of 29 yet to be finished. When rebuilding, we're going to convert to a new style gasket. Now, sometime back, some of our participants might not remember this, but back in the mid to late 1990s, we redesigned the E-Series solenoid valves and the B version as well. That new design incorporates a new enclosing tube and a new gasket. Here's kind of a cross-section of the new gasket. The new gasket is readily identified as a thin, synthetic coated metal gasket, and it's commonly known as a Wolverine gasket. The old gasket, it was a thicker O-ring with a square cross-section known as a tetraseal. The gaskets and enclosing tubes of the two designs are not interchangeable. The new enclosing tube assembly is included in the replacement parts kits along with that new gasket. Now, I'm going to say this was a major improvement to solenoid valves in general when this was done. This curtailed a lot of external leakage problems that came about as a result of refrigerant changes that had to start being done as a result of, well, of what, Glenn? Why would refrigerant changes have been made?
Well, you know, as we have these regulatory requirements to be more environmentally correct, refrigerants have changed over the years, you know, from the CFCs through HCFCs to all the way to HFCs and now on to hydrocarbons potentially in certain applications, hydrofluoroolefins, HFOs, and other applications. All of those things are different chemical species and can act on those O-rings differently. So we decided to take some of that guesswork out and take a more robust material with a better format and shape so we can actually reduce that interaction and provide a better seal.
So we stopped those leaks dead in their tracks.
Absolutely.
Good deal. Now, we've got an internal parts kit that has these components in it. We also have an enclosing tube kit with these parts in it, which is kind of a neat thing in both instances. So these are readily available. Now, unfortunately, it's difficult to look at the valve and determine just from external appearances which enclosing tube style and gasket style are included. You just about have to dismantle the valve to see that. But once you do, it's plain and it's clear. And depending upon the valve model, we've got parts kits identified for the application. And one good source of information on this is that Bulletin 122 that I mentioned that you can get from our website. Right. Now, there's one kind of twist to this. Most of these enclosing tubes thread onto the valve body, but there's one that has two body screws that thread onto it. Glenn, do you know what that fits by chance?
Well, Jim, that's on that W3 solenoid valve that we talked about a little bit earlier.
It's an industrial valve.
Mm-hmm.
Yeah, okay, got it. I forgot all about that. Now, Glenn, could you tell us about this product I've got up here right now?
Well, Jim, this is a pretty exciting new product we have called the Sporlan Pulse Width Modulation Valve. It's actually meant to be a metering device, so something on the lines of similar to a thermostatic expansion valve or a capillary tube that meters refrigerant typically.
But it's still a solenoid valve, right?
But it is a solenoid valve. And perhaps if we go to the second page, Jim, you can see why that might work.
Oh, look at all this stuff.
Because, Jim, what this valve allows you to do is to cycle that valve a huge number of times. Well, over 50 million cycles is where we've designed it to. Allows that valve to cycle many times a second to actually meter that refrigerant appropriate to the demand required. Okay, and you can see it comes with all the standard kind of things we would do, say, with a thermostatic expansion valve, including strainers, multiple port sizes, refrigerants. It's very corrosion resistant, very similar to a solenoid valve in the materials of construction. But It does have a very high pressure rating, meaning it can be used with CO2, which is a little bit new and unique. And then, of course, because it's such a high pressure capability valve, it's going to have a fairly high maximum operating pressure differential as well.
Okay.
And in the near future, we're going to come up with a webinar with more detail on this new product.
Okay, cool.
Because it's pretty exciting.
All right. Well, that's neat. And we're getting to the end of our technical discussion here.
We do have a few questions, Jeff.
Oh, wow.
I believe these are ones that are nice and easy to answer.
Okay, well, we've got some time. Let me go through the boilerplate stuff that if I don't say, I'm going to get in big trouble. So as we start to wrap this up, and be patient if you've posted a question to us, because we're going to get to them. You can view an encore performance of this webinar on Facebook or YouTube. It'll appear on our Facebook page first, and then a little later, because there's some extra work that we got to do to put it out on YouTube, it'll go out there. And it'll be out there for you to view again at your leisure, or you can see it for the very first time. You can stay connected to us. You can contact us by email at svdtechsupport@parker.com. You can call us on the phone. We've got a human that'll answer it and direct your call accordingly. 636 area code 239-1111. We're out there on Sporlan.com, and there you can find everything from technical literature to training material like we're talking about here. You can sign up for our newsletter. There's product videos, events we host in the spring and the fall, generally Sporlan specialist classes, and we have our virtual engineer sizing and selection tool available online, and all of that stuff that you can access from literature to software is at no charge. And you've already figured out how to get questions to us, so I'm not going to go over much of that. I'm just simply going to remind you to remember on April the 16th, we've got a webinar scheduled to cover thermostatic expansion valves, which is, once again, is a liquid line component. Now, I'm going to go back to this slide and say, Glenn, tell us about the questions.
Well, one of the things that came in was, can you pull a coil off while it's energized? And of course, we know the answer to that is no. That will quickly burn out the coil because it's meant to have that magnetic field around the metal material, so that would actually cause it to be a problem. So you would not want to.
You don't want to do that.
Nope.
You know what? I've seen it done. You know that? I've seen it done. I think they're the same guys that change out power heads on expansion valves with system refrigerant still applied. You can do that too. It's maybe not the best idea. So anyway, I'm being sarcastic to a certain degree there.
Right. So we also have another one is, do we have the controls that operate the PWM signals for the SPW valve? Yes, we do. And we will cover that in great detail in the webinar.
And the next one, I think that's a real good point.
Yep.
And we're moving in the directions of having packages like that more all the time.
Absolutely.
You got another question there, Glenn?
I think this just reiterates the fact that you do need different MKC coils for your normally open and normally closed solenoids.
Absolutely.
They will not work interchangeably.
That is absolutely. I'm going to pull that back up to show you, as we do have different coils.
Yep.
And like I said before, and we could even put the valve back up. If give me just a second here, I'm going to get to that slide that showed the two of them side by side. The normally open has a coil assembly that fits on the enclosing tube differently, as you can see right here. Whereas the normally closed valve has, did I just say normally closed over here?
Yes, you did.
I tell you what, you can't take me anywhere, can you? That's normally open, and the coil fits on it by leaves some protrusion of the enclosing tube. Right. Normally closed on this side, and Dennis, when he goes through this, he's going to have to edit out my faux pas there and fix it. Normally closed has the appropriate coil fitted to the valve body. Okay. You have another question, Glenn?
We did. How would a person know if they need the new gasket or not?
Well,
and that's where we look at the date code and you go back to your wholesaler and you tell them that information, and the counter person can work with you to make sure you get the right kit.
Yeah, here we got that slide again. As I said, it's almost impossible, short of a date code, to be able to look at this and tell that it has either a Tetra Seal or the Wolverine gasket design. Now, we made this design change back in the 1990s, mid to late 1990s, and it was finished. So if it's a more current design, it's going to have a Wolverine gasket in it. But the only way to tell absolutely for sure is to have system pressure removed from the valve and dismantle it. And visually, there's no question about it. You can easily tell once you've got those parts in front of you. But likely, if it's a more recent valve that you're servicing, it's going to have the Wolverine gasket.
Yep.
You have more questions?
We have one final question, but before we go there, there's going to be a few questions perhaps that we won't be able to get to, so we're going to ask you to subscribe to our YouTube channel.
Yep.
And you can get the notifications for when these webinars go up.
You bet.
And those answers get put out there. That way you have all the most up-to-date information possible. But do we have time for one more question, Jim?
We just barely got time for one more question, then we're going to have to wrap this up.
So Jim, when someone uses our virtual engineer, which is our selection web-based software.
Yes.
It says, what is the liquid temperature? Is this the summertime or the wintertime temperature of that liquid temperature?
Okay. Well, it depends. It depends what you want to model and simulate. And it depends on what component you're trying to select. Now, the liquid temperature that we're inferring here is the liquid temperature that would enter the metering device, presumably a thermostatic expansion valve, for instance. Now, I think it's good practice when you're modeling components to take advantage of the fact that it's quick and easy to do both a summertime design as well as something that might be off season if we're talking about air conditioning applications. It's good practice to look at a wide variety of conditions just so that you pick the right device. And it depends on what you're ultimately trying to achieve, which temperature is the right one for your particular system. But to go beyond just that, I think might be outside the scope of this discussion at this point.
Right.
Okay. And I tell you what, Glenn, that's about the last that we can cover at this point. So I'm going to say thank you to everybody that joined us today. Be sure and join us for the next webinar in April. And
don't forget to go back and look at this for any questions that you were asked that we have not answered. And you can do that by subscribing to our YouTube channel.
Absolutely.
To get those notifications of when they're put up there.
Absolutely. And by all means, be safe and take care of yourself and your family in these trying times. Thank you for joining us.